Alright guys, today's lesson. The learner will understand proving trigonometric identities. Proving is going to be a key thing. You'll see. Alright, so write the expressions in terms of sines and cosines only. So let's start with number 1 up here. Well, cotangent is cosine over sine minus sine over cosine. But it says express your answer as a single fraction, so we need to get these. So common denominator. Well, our common denominator is going to be sine x cosine x. So this one we'd have to multiply by cosine over cosine, so you'd get cosine squared x. Because cosine times cosine is cosine squared. Cosine times sine is sine cosine. Minus, this one's missing the sine x from the bottom, so sine x times sine x, sine squared x. So there we go. There's number 1. So number 2 now, you have pen helps, sine x times 1 over cosine x minus cosine x times 1 over cosine x. So they already have the same denominator there. So this would be sine x minus cosine x over cosine x. Alright, so let's look at the third one here. Well, this would be sine x divided by 1 over sine x plus cosine x divided by 1 over cosine x. So that would equal sine squared x plus cosine squared x, which equals 1. Okay? Alright, it says determine whether or not the equation is an identity. If not, find a single value for x for which the two expressions are not equal. Okay. So if I look at this, natural log of x squared equals negative 2 natural log of x, that means I can move, remember, I can move this down, so it's 2 times the natural log of x equals negative 2 times the natural log of x. Well, if we just say that x is equal to e, the natural number, you have 2 natural log of e equals negative 2 natural log of e. Is 2 equal to negative 2? No. Square root of x squared equals x. Is that true? No, because if I said negative 3 squared, well, what, negative 3 squared is 9. What's the square root of 9? 3. Is 3 equal to negative 3? No. So neither of those are. Okay. There we go. I think we got them all right. Alright, so what you learn about? A proof strategy. Proving identities, disproving non-identities. That's what we just did before. And identities in calculus. So it's things you'll have to use in the future. And why proving identities gives you excellent insights into the mathematical proofs that are constructed. Alright, the proof begins with the expression on one side of the identity. The proof ends with the expression on the other side. Okay? The proof in between consists of showing a sequence, each one easily seen to be equivalent to its preceding one. Must show work. Are we clear? General strategy 2. Begin with the more complicated expression and work towards the less complicated. If no other move suggests, convert the entire expression into one involving sine and cosine. combine fractions by combining them over a common denominator. Okay? So here, there's those properties we've learned that we are going to be using a lot of. So what this is saying is, forget about this side, focus on the first. So I look. I start with this. Well, I see that 1 plus cosine x is on the top. So I'm just going to multiply. Because what I did was, we have the first, I'm looking at the second. I somehow have to get 1 plus cosine x to the top. So that's what I did. Because isn't that multiplying by 1? We can do that. So I have sine x times 1 plus cosine x over 1 minus cosine squared x. Well, what does that equal? Well, according to this right here, that equals sine squared x. So I can cancel that out with one of those. So now look, I have 1 plus cosine x over sine x. Or you can use instead of equals, a symbol therefore. That's what those 3 dots mean, is therefore. So we proved it. Okay? They did the same thing. Sometimes there's more than one way to do things, so you never know. All right, general strategies 3. Use algebraic identity. So that's kind of what we did when we had 1 minus cosine x and multiplied by 1 plus cosine x. Always be mindful of the target, so always have the other side impression. And favor manipulations that bring you closer to the goal. Okay? That's basically what we just did. Here are some more identities that you're going to need to be able to copy down to possibly use. So tomorrow I'll be ready to do some proofs. See you then.